Limits allow us to evaluate a specific y value as x approaches from the right and the left hand of the graph, coordinating x value, x equals a, to that of y. However, the limit only exists when the right hand limit and the left hand limit of x equal a are equal to each other.
For more simplification, f of x, where the y values approach t, a specific y value, while x or the x values approaches a specific x value, x equals a. The specific y value as the x value approaches from the left, and the specific value as the x values approach from the right, of the defined x value must equal.
There are two different types of limits, finite and infinite limits. Finite limits are when a limit is evaluated based on a specific x value, x equals a. It's shown as the limit of f of x as x is approaching a equals a specific y value.
For infinite limits, it's when a limit is evaluated and a horizontal or vertical asymptote is produced. Over here we have the notation for a horizontal asymptote. It would be the limit of f of x as x approaches positive or negative infinity, and that would equal a certain y value. For vertical asymptotes, the limit of f of x as x approaches a specific number would equal either positive or negative infinity. And in some cases, the limit wouldn't exist because the right-hand limit doesn't equal the left-hand limit.
In order for the limit to exist, the right-hand and left-hand limits must equal each other at a certain x value, let's say 1. So from the left hand, the limit equals 2. The limit must equal a specific y value, which is 2. And coming from the right hand, it equals 2 also. So the limit exists at x equals 1. In this graph, we're finding the limit as at x equals 7. Coming from the left hand, you can see that the y value equals 9, and coming from the right hand, the y value equals 5. So when the right hand limit and left hand limit don't equal each other, the limit does not exist. On this graph, if we were to look at where the limit at x equals 2 exists, we would see that coming from the left hand, the y value is 2. Coming from the right hand side, the value is 3. So that means there's a discontinuity. And if we were to look at x equals 3, we can see there's a 3. There's a discontinuity. But coming from the left hand side and the right hand side, the y value equals 4, and even though there's a discontinuity, limits are about closeness, so that the limit exists.
Alright, over here we got infinite limits. If we wanted to find out the limit of f of x as x approaches negative 8, which would be right here, you'd have a vertical asymptote. And right here, at the left-hand limit, as it approaches from the left, would be negative infinity, and over here would be positive infinity. In this case, the limit would not exist, because in order for a limit to exist, the left-hand limit must equal the right-hand limit. Over here, we got a horizontal asymptote, as if we were trying to find the limit of f of x as x approaches positive or negative infinity. Over here, as the function is approaching negative infinity, it's getting closer to 2 but not getting there, so that would be, so it would be approaching 2 from here, and then on the right hand side, it would be approaching 2 also. Therefore, the limit of that is positive and negative infinity. That would be 0. Over here, we have a harder version of a function because it includes vertical and horizontal asymptotes. Over here, we have a horizontal asymptote at y equals 0. As x approaches negative infinity, it approaches 0. And as x approaches infinity, it's 0. So the limit of f as x approaches either positive or negative infinity, that would be 0. Over here we have vertical asymptote at x equals 0. The limit of f of x as x approaches 0 is going down to negative infinity, which is the left-hand limit. Right-hand limit is also negative infinity because the function is also approaching negative infinity. So therefore the limit does exist because the left-hand limit equals the right-hand limit. On the other hand, over here at x equals 2 we have another vertical asymptote. On the left-hand limit it approaches negative infinity. On the right-hand limit it approaches infinity. Since the left-hand limit and right-hand limit do not exist, the limit does not exist.
Tables are also another way represent right hand and left hand limits, like the graph. As you can see here in this table, we have a left hand limit and a right hand limit. As the left hand limit becomes bigger, so x value, y is the other the number 4 closer and closer each time that value becomes bigger. For example, 0.5, you only have 3, but once you get to 0.999, you have 2.998. Also, the right hand limit, as it becomes smaller, it approaches 4 closer and closer, and it goes from 4.4 to 4.0002.
Okay, over here we have another table. Over here is the left hand limit. X values are as x approaches 0. Negative 0.5 is 0.9588. And as it increases and gets closer to 0, it's going to approach 1. 2.9588 corresponds to negative 0.5 over here. So it gets negative 0.01. It's 0.999983. That's a lot closer to 1. For your right hand limit, as the x values approach 0, it doesn't approach 0, it's decreasing. The y values are increasing, approaching 1. So since you have the left hand limit, right hand limit, both approaching 1, the limit is 0.
The reason that right hand and left hand limits are important is because they show if a graph is differentiable, or you can take the derivative of a graph. Also, it shows on the graph if there is a hole or jump, basically a discontinuity.
Alright, after a long night of studying, helping you out with limits, I guarantee you got your limits down. Wake up in the morning, you're going to feel like PJs.
I'm gonna hit this city before I leave. Brush my teeth with a bottle of Jack. 'Cause when